Let's start with the video, and in this video I will share how you can group something in Houdini, how you can group uh, by primitives, how you can group by points, and how it will be helpful for you if you create big projects. And grouping is really necessary in Houdini, and it's really important that we should know what a group do and how it works in Houdini. And in this video we will create a procedural stair so we can uh, get to know how this group work, so we can understand it better. So first I will just create a geo node just to give you an example how everything in the group SOP works. So inside the geo node we would create our test geometry rubber toy, and I would create a test geometry big head, and you can just disable this shader for both, right? So we have our geometries right here, and what I want to do now, I want to merge these two so we can see them together, right? So now it is merged, and my goal is to move the pig head to the y direction without changing the translate for the rubber toy, without changing the direction of the rubber toy, without moving the rubber toy. We want to move the pig head, but not from here. Translate. Trans. Wait. Trans. Transform by this transform node, and I want to move the pig head in the y direction by this transform node, and I want to translate this pig head in the y direction. So what we can do now? Now these two geometries are merged, and we want to translate only the pig head to in the y direction, right? So what we can do? Now, when we have our geometries combined, my goal is to translate our pig head in the y direction by this transform node. So what we can do, we can put all the parameters or all the points of this pig head geometry into a group, and then we can translate that group without moving this our test geometry rubber toy. So let's create a group node. This is a group node, and I will tell you what this base group do later in the video, but first we need to work with the basics of this group node. So I want to translate this. So one thing first, this group node is connected to our test geometry pig head. So everything this pig head contains, like now we are in primitives, the group type is now primitive. I would give this name pig head, okay, and this group name pig head group, and now the group type is primitive. You can change to points or primitives. Now when I toggle the display option, we can see everything, every primitive of this pig head is now grouped into this pig head group, right? But if I want to have only a few primitives, only a selected primitives to be in this group, we can do that. We have different options. I will tell you these later, but now these two geometries are merged, and this is like this exclamation mark is for just because this test geometry have different attributes, this test geometry have different attributes, and we are combining different attribute geometries together. So it's just panicking. We don't need to do anything about it. We can delete its attributes, or we can change its attribute, but we don't need to do it right now. So what we can do, I told you in the very beginning that I want to translate the big head in the y direction by this node. So what we can do, we can hit this transform node, and in the group, in the group bar, we can select our group, which is big head, this big head. Now when I translate on the y-axis, our group, which contains all the primitives of this big head, is now moving in the y direction. And I will show you one more thing. This big head node, this big head node now have 5 primitive groups: big eyes, big head, big neck, big face, big throat. Because it's already have its own groups, when we create this geometry, it already comes with its own groups. What I want to do now is delete all these groups, including this. We can delete its group by a group delete node. We can delete this by just deleting this node, or we can delete it by creating a delete group delete node, group delete SOP. And when I toggle this on, you can see we still have 5 primitive groups. So how is this not deleting anything? So we have this option, group name. So what you can do now, you can type your group which you want to delete, or you can just type star and press enter, and now you would see we have 0 primitive groups. Here we have 5 primitive groups. Here we have 4 primitive groups, because one group we have created by ourselves, and this node we have just deleted everything by typing star. Star means to delete everything. And let's create a group for our test geometry rubber toy. And I want to show you something. Now in this group, we have everything, like all the parameters. I want to group this by a bounding box. Or you can give this to bounding object and we can connect our object. So everything in this bounding box is now grouped into everything in this bounding box is now grouped. Every primitive inside this bounding box is now grouped. You can increase its size, change its center, change its location, increase side in the y, z, or x axis. So everything inside this will be grouped. And if you want to see like this group name, we will give a rubber toy, and we can say primitives. So now toggle this, right? And inside this base group, we can have toggle this, and inside this bounding box everything. Go to this node and transform this by rubber primitive. We can see now we are translating every primitive that was inside that box, right? So everything inside this box is one group, and we are now translating this group in the y direction. So I don't want to do that, so just delete this. And now I want to show you something else. We have group by range also. So how these are different? I want to show you one more thing. Let's give this a group, and I want to now have primitives. Like you can also change these 2 points, but for this video, let's say primitives. And I want to, my goal is to group all these primitives which are on the top of this test geometry inside this single group, and I would give this a name top faces. Okay, I want to have all the top faces and all these faces top, the faces which are facing the top into this group. We have this option keep by faces, and when we enable this, we can type which face we want to, but we have also by direction. When we toggle this on keep by normal, so what this would do, this would select every face on, like if a face is facing y direction, like if a face has normal which is facing y direction, you can see the normals by right there. You just toggling this on, and you can see these faces are facing their, like these faces normals are facing the y direction, right? And these faces are like z and x. So these faces are like y facing y direction. So we don't want the z direction, right? So we can just hit 0 and we can type here 1. And when you toggle this group on, now you can see everything is selected because the spread angle is 180. That means we are like on the extreme of the selection. When we decrease it, you can see now we are selecting all the faces, those faces of like we are selecting only those faces whose normal are facing y direction. And we when we decrease the spread angle, that means we are now getting to a extreme point. Like when if a face has normal like this, when we increase the spread angle, that means if a face normal is slightly tilted on the y direction, it is also like selecting that face also. So when we decrease the spread angle, that means we are being so specific. And when we decrease it like 10, that means these faces normals are very like they are extreme to that facing property. So that means these faces normals are facing very particular to the y direction. So now we have selected all the faces by normals. Bounding box I will tell you, by edges you can by random chance. And I want to tell you something else now. This bounding box, but I want to create my own bounding box. We can have a sphere, and when you connect this sphere to this now, and we have this bounding sphere, bounding object. Now this is giving us an error. Top faces. Oh wait, enable top faces primitives. Okay, so this error is because in the bounding box type we are having an error because this option only allows you to group point and vertices only. So when I hit the points option, now we can group these points into our group top faces. But if we want to have primitive and have our own geometry, we cannot do that. So for this part, I think we are done. Now this part, group range. So I will show you one thing. We will create something and we will understand what this group range do. First delete this. Okay. Let's create a helix. Okay. Now we are creating our procedural stair. Okay, procedural steps. So what we can do now, turn this display on, and I want to have, so I want to increase the height of this helix, and let's say 4. Okay, turns I am fine with 2. This would be our base. I want to increase the radius by double, and let's create a geometry around this curve. Like in the past video we have created a geometry by a point. by a line. We created a geometry by this line. Now we will create a geometry by this helix. So to create a geometry, we have our sweep, which can create geometry from a line or helix. So let's toggle this on, and we have now a round tube, which we don't want. We want a plain staircase type structure. So let's get with ribbon. And in the helix, we have our output attributes. Just the orientation of this is not what we want. So I want to disable the orientation because it's taking the orientation attribute from this node, and I don't want to do that. So I would give this helix a orientation by enabling its orient node. And sorry, I was wrong. This helix has its orientation node, which is now facing on a like its particular direction. And when we disable this, now it's facing like it is depending on the points that this helix has. So when we toggle this on, now this helix has its proper orient attribute. So I want to increase the width now and decrease the columns to 1. Now I want to like extrude this helix, this mesh. We can give this a poly extrude. Okay, just extrude this, and when we toggle this on and we hit its property, and you can give this extrusion from there or from there. Okay, now you see the bottom of this is empty. We can fill this by toggling this output back. So this will connect these edges, and it will fill up the geometry. And we have our proper stair base with thickness, right? So now my goal is to select each of these faces alternatively, like by not selecting, like selecting one out of every two. So when I um, so how can we do that? We have two options. You can put these faces into a group by this a group node, select this. Okay, and you can go inside this node P. Now everything is in every primitive of this helix is now in this group. You can select your primitive by selecting like your own and doing it manually. It would take time, it's not convenient, it's not good to do like this when we have like proper tools for that. So it's not convenient, but you can do that. It's a long way. Now we have our short way, right? So what we can do, we can give our SOP group by range. Put this here, delete this node, we don't need this. Now everything inside this is grouped, right? We have this range filter, so I will tell you how group range is different than the proper group. Group is like a proper way to group anything. You have all these options. You can group by geometry, you can group by points, you can group by like an extra geometry, you can group by a bounding box, right? You can group by normals. But if you want to group, like you have 100 points scattered on a plane, and you want to group like every 1 point, okay, in 5 point, you want to group each one of 5 out of 5, or you want to group first 10, then don't want, then the next 20 to 30, then you don't want to group the next 10, and then after that next 10 you want to group those. We have this group range. So you group by this node, you group by range. Like in this example, I want to group 1 out of 2, right? 1 out of 2. I would say select 1 of 2. Now we have 1 out of 2. But here's the issue. We just want to group the top primitives of this helix. This top layer, I want to group only 1 out of these 2, but only the top part of this helix. As earlier, what we did, we did create a group. Okay, in this group, I told you we have this option keep by normals. It's very handy here. So when you enable this, which direction we want to group? Y, because only the Y faces are facing the positive Y direction. We have like minus Y direction. You can give it a minus option. Like if you want to have these faces grouped, you can decrease the spread angle. Now it's extreme, and when you do this, now we have our bottom layer selected, right, in a group. So I don't want that, we want the top layer. So hit 1 and you decrease the spread angle, right? So we can select the extreme, only the faces that are like near the normal facing on the y direction, or like properly facing those primitives that facing the normals of those primitives that are facing the y direction. So now we have this selected, right? These are in the group. We can give this top primitives, and we can give this group a base, and over that base we can create another group. So for example, we created our group range selector and we said to this group range to select every 2 out of 1 to 1 out of 2, every one primitive out of 2 primitive which are faces, every one face out of 2 face to select and create in a group. But it selected all, like every face, like it is now working on this whole helix, all parameters, but we want this to work on the group now we have created, which are group 2 top primitives, and you can give this the base group top primitives, and now you would see this group is working on top of this group, right? And which is now very handy, and this would, like, now we can complete our goal, which was to create a staircase. Give this poly extrude node and hit this, toggle this, and when you increase the distance, wait, you can, okay, you have to give this a group because now it's working on everything, right? Because each node have to have an input and an output. We give this input group range, like this is taking input from this poly extrude, because these are just group, and we have to tell this that you have to extrude what we want, which is our these primitives which are in the group 1, and we can stairs. Okay, now toggle this on, and when you increase the distance, it's extruding everything, and you need to give this stairs. Now it's extruding only these two. So I guess in this video now it's clear how we use our group range selector and our like group node, and it's very important that we understand how these two works. because they are really useful when we create big projects like this staircase. How would you select each parameter without this node? We can select it by giving this, like we can by picking it like manually every parameter, but it would take a long time, and Houdini is not for that. No, 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 no. You are working here procedurally, and that's why these nodes, we have to understand these. It's really important, right? So that's it for this video, and I really hope that you understand what I'm teaching. I am improving, I am trying to learn. Okay, I'm trying to improve the way I teach. It's really important for me to create some tutorials, because that way I would like improve my communication, my fluency, and it's really important for you to keep learning, to keep creating, because life is all about creating and becoming a good and a better human being that you were before. And by this motto, I'm also on the same. And I'll see you in the next video. Until then, take care.